Look at your lab handout. You've got your purpose, and it's the skeleton, just like what you've had before. We're going to come over here to the procedure and start looking at the procedure. Of course, you've got materials there, and all that kind of stuff. So let's focus in on the procedure. And you're going to write a summary of this. It's not going to be word for word. You need to do a paragraph summary of this. So on your procedure here, the first step says tape a card to the back of the card shown in figure 1. You may or may not have to do that. You might have to do this if you're getting a lot of spikes on your graphs here. Then you just kind of tape this to the back of the card. But if you're not, you can test it out. Click collect, test it out. And if you're not getting a lot of spikes on that graph, then you don't need to worry about it. So I'm getting a nice smooth graph right here on position time. I don't need to worry about taping anything to the back of that as of yet. All right, so then you want to find the mass of the car, hanger, 3 supplied masses, and the string. And you do that by putting it on the electronic balance. So we come over here, turn it on, wait for the electronic balance to read 0. And we'll put the string and the car up here. And you might have to try and balance it all a little bit, try and keep it from falling off. And we get 562 grams, and then it says to record that in our data table. So we'll go record this in our data table and our lab skeleton. So right here, record 562 grams. And one thing that it says to do here is to record the value to the nearest 0.1 kilograms. Well, I recorded in grams, and I need to convert this into grams, so we've got to remember that 1,000 grams is equal to 1 kilogram. So 562 grams would be equal to 0.562 kilograms. You've got to make sure to convert that. We don't actually want this one. And that's what you're going to put in your lab write-up. You want to put it in kilograms. So number 2, you're going to attach the hanger to a string, and this is probably already done for you. The hanger will hang over the edge of the table as shown in figure 1, and it's actually going to hang right over this pulley here. Okay, and that's going to help pull the cart along the track. Place your cart on the track, make sure that you can easily read the ruler that's on that track, and we're going to connect the motion detector to the LabQuest Mini, and that might already be done. Then you'll connect this to your laptop with the USB cable, get that all connected. Now, we want to make sure that the motion detector is at least 10 centimeters away from the car. I usually do about 15 centimeters to make sure that it reads properly. So we don't want to get that car any closer than 10 centimeters to it. And for this one, it looks like we can't get any closer really than 30. So that's great. Now, place all your masses on top of the cart here, and make sure that the hanger is empty, that there are no masses on that hanger. Let's keep on reading here. If the hanger does not have enough mass to move the cart, transfer one of the masses to the cart. If we look at this, it has enough mass to move it, so we're good there. Okay, now, we need to prepare the computer for setup for the lab. So we're going to open up lab file number 39, Newton's second law, under physical science with Vernier. So we do that on your computer here. We click the open button, and it'll open up all these files, and we've got to go look for physical science with Vernier, and here it is. Do not choose the physics one, please choose physical science with Vernier. And if you open up the correct one, go to lab number 39, way down here at the bottom, it'll say Newton's second law. If it does not say 39 Newton's second law, you open up the wrong folder. Go back, look for physical science with Vernier. So we'll double click on that, and it'll probably ask if we want to save changes. We don't want to save changes. Okay, so we get this file open, and we've got these 3 graphs: position time, velocity time, acceleration time, which you're familiar with. You've seen this in class before. Now, we want to place your cart in the starting position on this track. So we're going to choose a position that is the same every time. And I'm going to choose this position based on where the hanger is over here. I want to make sure it doesn't come in contact with the table. If you can see right here, it's coming in contact with the table. So the hanger needs to be a little bit below it. And I need to look over here, and I want to choose kind of a spot where we've got a nice even number. So I'm going to choose right at 35. So this is not in contact with the table. It's far back, it's at 35, and I can start this car at 35 every time. So I'm going to let go of that, and I know I can start it at 35 and be fine. Come back and read the rest of the directions here. So place your car at the starting position, click collect on Logger Pro, so I'm going to get that ready. And release the car after you hear sound coming from the motion detector. So you don't let it go as soon as you click collect. You're going to wait until you hear sound coming from your motion detector before you let it go. So don't go like ready, set, go. Just click collect and then listen. When you hear it, then you can let go. Okay. All right. So then we have some data here on this graph. All right. So let's make sure to click auto scale, and hopefully it'll make all of them big. But if it doesn't, we can come back and click on individual ones, and then come back and click on auto scale. But it should initially make everything big, nice and auto scaled out. So look, we've got this nice curve here. This is linear here. This is a flat line here. So that's good. We've got 3 graphs that look good, and it looks similar to what's on your paper here. Now, we want to determine the mean acceleration, the initial velocity, and the final velocity of the car. And we can use these figures down here to do that. It says, use the start and end markings on figure 2 to help you identify the initial velocity and final velocity. So we can do that here. Let's click on our examine tool, and notice it makes it so that we can examine these individual places. So we can see that basically corresponding starting point would be right about here. So our starting velocity would be 0.0070 right here. So I'm going to take this value and I'm going to record that for trial 1. 0.0070. Okay, and then let's look for the final velocity. And that should be right up here close to the top, but before it starts rounding off. So somewhere right about here is going to be our final velocity. And our final velocity is reading 0.2756. 0.2756 meters per second. Now, I notice I've left something off over here, and that was one of our directions on the first page to make sure that we put the mass of the hanger in the data table here under number 5. So come back to that.